did a much better job. A couple weeks ago, I was giving a talk at my son's 8th grade class, and my wife actually had to read that same introduction to me, and she got about halfway through it and started cracking up. Anyway, so thank you. It's an honor to be here. I'm happy to give this presentation that, as Andrea said, is a bit of a reach for me, a little branching out. As you kind of heard from my introduction, I've been a chemical oceanographer for a number of years, studying climate change and ocean acidification, uptake of man-made CO2 into the oceans. But I thought, well, I know that Ken Caldera gave one of the early ITER talks here and talked a lot about the science behind ocean acidification. And Kathleen Moore was here just 2 weeks ago talking about, from a philosophical standpoint, the role that we're playing in changing the oceans. And so I thought maybe I would try and connect those two a little bit and talk a little bit about the social aspect of climate change and ocean acidification. And again, kind of bring together that science and philosophy a little bit, and give at least my opinions on why I think it is that people are not acting as much as we perhaps think they should. Now, in doing this, I have to give a couple of caveats, or disclaimers. The first one is, I am not a social scientist, even though as lab director I am frequently asked to play one on TV or to Congress. I'm speaking here just in terms of my experience over the last couple decades dealing with climate change issues and my reading of various social science documents and my interactions on a number of different international committees with real social scientists, but have to put in that disclaimer. Second disclaimer is, as a Fed, it should be very clear that I am not speaking on behalf of the U.S. government. I have to say that. And so these opinions clearly are my own and represent, again, just my personal views and what I hope will inspire a bit of a dialogue, of discussion. We'll see how that works out. So, again, kind of starting off with the talk that we had a couple weeks ago as part of this series from Dr. Moore. She talked about the moral imperative we have to save the planet and our oceans. And so it got me to thinking, you know, why do we have trouble acting? I think most of us here probably feel that they have a moral obligation to try and save the oceans, to try and protect the planet. And yet many of us aren't really doing much. Why is that? And she talked about her hope-o-meter, which I love. She had everyone in the audience raise their hands on a scale of 1 to 10 where they were in terms of their hope, with the idea that, you know, if you're a 0, basically you say that there is no hope, that it doesn't really matter what we do, nothing's going to change or save the oceans, therefore why try? Or if you're a 10, and then you also are not likely to act because it's all going to work out in the end anyway, that technology or something is going to save us, and so why should I be worried about it? Everything's going to be fine. But it was my observation that most of us were somewhere here in the middle, in the 5, 6, 7s range. And those are the people that I'm really going to be talking about today, and trying to understand what it is that holds people back. So I'm going to start talking here with the perspective of 1997. So this is when the Kyoto Protocol was first introduced and ratified. I note here that the U.S. is the only signatory that's left that hasn't actually signed the Kyoto Protocol, but At that time, about half of Americans believed that the climate really was changing, and fewer still believed that it was humans that were causing that change. It really was not clear which Americans were believing it. It did not seem to be politically driven, but that all seemed to change around the time of Kyoto. What happened since then? Well, since then, of course, we had the third assessment report from the IPCC that made a much stronger statement than previously. Says that there is new and stronger evidence that most of the warming observed over the last 50 years was attributable to human activities. In 2006, we had the premiere of Al Gore's movie, An Inconvenient Truth. Again, brought this issue to the general public a lot more so than had been done in previous years. And then in 2007, that was immediately followed up with the fourth assessment report, which declared that the warming of the climate system is unequivocal, and that most of the observed increase in global average temperatures since the mid-20th century is very likely due to observed increase in anthropogenic greenhouse gas concentrations. Now, that very likely is a part of IPCC jargon that has a very specific definition. In this case, is 90% or more confidence that that's occurring. So that brings us to a survey that was done looking at the public belief in global warming. And so in that 2006-2007 time range, there was about 77% of the public that felt that there was solid evidence that the Earth was warming. And about 47%, a little less than half, that felt that that warming was mostly caused by human activity. But that seemed to be kind of the peak. So as we look through time, this same survey has been conducted every year. We saw a precipitous drop in the belief of Americans over the next few years. And there are a number of theories as to why that occurred. It's, of course, the time period when we had our economic collapse. And, you know, there are theories that, well, when you don't have a job, you tend to worry a lot less about climate. There are theories that have suggested that it actually was that Nobel Peace Prize that was awarded to the IPCC and to Al Gore in 2007 that started a political machine actively working against understanding of climate change. In fact, I was recently just at a meeting with some researchers from George Mason University, and they were telling me that the amount of dollars that were spent on the anti-climate change campaign tripled after that 2007 Nobel Peace Prize award. Anyway, so it went down, but then it started to creep back up again. But interestingly enough, if we look at a different question that was asked in the same survey of how serious of a problem is global warming, you see the same peak around 2006, 2007. You see the big drop towards 2009. But the seriousness of global warming really has not recovered in the same way that the belief in global warming has changed. Some other kind of interesting observations over how this has changed. Again, I mentioned that back in 1997, it did not seem that there was a very strong political aspect to the belief in global climate change or global warming. But after that, there definitely was. In fact, you see that for Democrats, interestingly enough, we see this increase again to 2006, 2007 in this range, and then it basically has leveled off. That the Democratic audience really has not changed their opinions too much, hanging out around the 70% level. But the Republican audience really has dropped off dramatically, and these are the latest results from a survey that was done in September of 2012, showing that only about 1 in 4 people that self-designate themselves as Republicans actually believe that climate is changing at all. I think another interesting aspect of what we've seen in the past few years is a move towards more extremism. That, you know, either you're with us or you're against us. You know, if you still believe in global warming, then basically you're like the Unabomber. Or if you don't believe that climate change is happening and that you're not being actively trying to do anything about it, then basically you're killing the Earth. And I think this move towards more radical, more extreme views has really polarized the country. And while most of us are sitting in that middle range in the hopometer, it's a bit scary perhaps to get associated with one or the other extreme. So what about ocean acidification? This is some recent work done by the Ocean Conservancy, done through a research group called Edge Research. And what they did was they went out recently and asked random Americans how they would rank these different threats to the ocean, and which are the most important, which are the least important. And you see that ocean acidification came out here pretty low in the rankings, actually even below global warming, which is interesting. Now, another thing that they found in this same study was that most of the people that they spoke to actually didn't even know what ocean acidification was. So they kind of followed up on that with another question, saying, okay, well, how about if we explain that ocean acidification is where rising atmospheric CO2 is moving into the ocean, that CO2 then acidifies the oceans and changes the chemistry. And what they found was that about 69% of those people, once this was explained to them, felt that that was believable, that really could be happening. And of those people, 76% of them believed that it actually was humans that were causing that acidification of the oceans. Now, what I find interesting is the fact that even though 70% of the people believe that this really could be happening, only 56% were really worried about it. In fact, only 20% were really worried about it. And fewer still felt that it was something that really affected them. And that's another issue with ocean acidification, I think, in the oceans in general, is that I think a lot of Americans have kind of a disconnect. They don't really see how changing oceans and affecting fish really has any impact on them. So my point in giving all of this background and of my talk today is that I think we as climate scientists, as future climate scientists in the IGRIT program, people that are interested in understanding the oceans and improving the health of the oceans, we need to have an appreciation for where people are and what their perspective is when we present our information and our findings to the general public and to policymakers. Kathleen Moore talked in her talk about how we can't just keep piling on more and more information, that that's not the solution, that we've got to make this a moral imperative. And I agree with that, but you also have to understand why people act or don't act, and perhaps try and address that in how you're presenting your results to them. So what I'd like to do is to suggest that there, and again, these are just my opinions that I'm throwing out here for hopefully a bit of discussion at the end of this. I see that there are 4 major challenges for presenting the issue of climate change and ocean acidification to the public and to policymakers. I'd like to get your thoughts on these. So the first one is, I think that first impressions just from the name are important. Carbon is not a traditional pollution issue, and it is basically what we call the ultimate commons problem. And I'll go into each of these in more detail. The third challenge, I think, is that it's difficult to convey the magnitude of the problem. This is something anyone that's ever heard me speak knows that this is something I'm very passionate about and that I try and convey in all of my talks. And I think it's an important point that is missed frequently. And then fourth is just the complexity of the whole problem that's a challenge. So let me talk about each of these a little bit. First one is the name. And I find it very interesting that when we first started talking about global warming, that a lot of the nations from the higher latitudes, Canada, Russia, even Australia and South America, were saying, well, you know, maybe warming up the planet is not such a bad thing. You know, Siberia would be a lot more comfortable if it were a bit warmer. And so there's this sense that what I've found in my talking with the public, and I've given public seminars on climate change and ocean acidification over the years to a wide range of communities in all over the US, in Australia, in Japan, in a number of places. And consistently what I find is that a majority of the people that I speak to honestly never really get past the name. You know, they form an opinion based just on the name. And if they feel that global warming, warming the planet might be a good thing, then they're not inclined to take it any farther than that. So then what do? We changed it, right? So first we started pushing global warming, now it's climate change. And that's even harder for people to grasp. You know, the idea that rising CO2 can cause droughts in some places and floods in another place is really out there and very difficult. It doesn't make intuitive sense to a lot of people, and I think a number of people just get stuck there. Now we compare that to ocean acidification. I love this cartoon. I don't know whether it really was planned or not, but it's interesting, the reaction that we've been getting to ocean acidification from people that have never heard of this before is, gosh, I don't know what that is, but it sounds really bad. And so it's a really interesting dynamic that I hadn't even really considered, how the name really makes an impact on those that are not willing to really put in that effort to fully explore a topic that we found that the majority of Americans that were just presented with the idea, is ocean acidification bad or something we should worry about, that 50% number we saw in that survey, I'd be willing to bet that the majority of those people had no idea what ocean acidification is, but said, ooh, it sounds bad, yeah, I think that's bad. So that's been a bit of a challenge, I think, for climate change or for global warming that has been an interesting little benefit for ocean acidification. Second challenge, it's this idea that carbon is not a traditional pollution issue, although it should be. In 2007, the Supreme Court decided that carbon dioxide was legally an air pollutant. This was a major case. This was a major step forward in climate change policy to actually have this gas labeled as an air pollutant. But you think about some of the other cases where this has happened, and we see very different results. So think about acid rain as an example. You know, it's very similar. It's a gas that comes out of power plants and it reacts with the water molecules to form an acid. In this case, it's the sulfur and nitrogen gases making very strong acids, sulfuric acid, nitric acid, that basically was killing everything downstream of it. But if you think about it, this is a very different issue from CO2 because the impacts were primarily local. You could see directly downwind of these power plants all the dead trees and the impacts on the dead lakes. And so there was a very clear cause and effect. And it was very easy and clear for people to see that, hey, this power plant is killing everything around me. And it was affecting people right where they live. So I think CO2 is a little bit of a different issue than we had with acid rain. Another example is CFCs. Now this is more like CO2 in that the CFCs were globally mixed. We weren't just seeing these local impacts, but it was a little bit more remote. You know, we had research that was beginning to show that CFCs were destroying the ozone layer. Most people didn't even know what the ozone layer was before hearing about this issue. And so in that respect, it's kind of similar to the CO2 in that it's a remote effect, and it's happening globally. The difference here, I think, is the fact that it was, the sources were pretty localized. At the time that the international treaties were passed for regulating CFC emissions, there were really only 4 major manufacturers of CFCs in the world. And the fact that the CFCs were completely human-derived, there are no natural CFCs, there was a very clear cause and effect. This company is making this compound that we can measure in the atmosphere. There's no place else it can be coming from except from that company, and it's destroying the ozone layer. So even though the research on the impact of CFCs on the ozone hole was frankly not very complete at the time the treaties were passed, they actually managed to pass international treaties banning the use of CFCs. And in fact, that research was even at a more juvenile stage, I would argue, than the CO2 climate change research is right now. But you had that effect. And people were claiming the 3M and companies that were making the CFCs at the time were saying, this is going to destroy the economy. You know, we're going to lose refrigeration, we're going to lose our air conditionings, it's going to devastate the economy. But it didn't. They very quickly, in fact, before the bans even fully took effect, they had alternative refrigerants. And I don't know, did any of you see any impact from changing CFCs? I mean, you had to go in and recharge your air conditioners with a new gas, but it really didn't affect us. So why is CO2 different? And for that, I want to step back a little bit and talk a little bit about the global carbon cycle. So this is a cartoon of the pre-industrial carbon cycle. So this is during pre-industrial times prior to the Industrial Revolution, say in the 1700s. And at that time, we see that there was about 590 petagrams of carbon in the atmosphere, CO2 concentrations. It's roughly a factor of almost 2 to 1, so that's the CO2 concentration in parts per million was about 280 parts per million at that time. That the trees in the terrestrial biosphere were taking up CO2 out of the atmosphere. They would then drop their leaf litter, which ultimately moved carbon into the rivers from the soils out into the ocean, and the oceans were actually a net source of CO2 to the atmosphere. So we had this natural cycle of CO2 with CO2 taken up by the terrestrial biosphere, moved out into the ocean, where it was released into the ocean. And for at least the last 11,000 years, we know that atmospheric CO2 was extremely constant. So this cycle must have been in balance. Now what have we done? We've added on top of that now these additional fluxes. We've tapped into this reserve of fossil organic carbon in the rock record, and don't let people fool you into thinking that we're about to run out of fossil fuels. They've actually been finding fossil fuels at a rate faster than we've been burning them, and making more and more fossil fuels available. You know, we didn't have 10 years ago fracking, and so those reserves were not originally counted as part of the reserves, but now that we've got fracking, that changes the whole story. So this is the average for the first decade of the 2000s, so 2000 to 2009. Average emissions were about 7.7 petagrams of carbon per year, which has resulted in fluxes into the terrestrial biosphere, and we've actually even reversed the role of the oceans, where they used to be a net source of CO2, they're now a net sink for CO2. So we still have this natural carbon cycle, but superimposed on that, we have these anthropogenic fluxes that are taking carbon out of the rock record and changing that cycle. So the problem is, one, the CO2 is everywhere. It's involved in many processes. You know, we learn in grade school that trees take up CO2 and that we breathe out CO2. We know that there's a natural cycle of carbon that moves through the atmosphere, terrestrial biosphere, and the oceans naturally. So to explain to people how adding a little bit more CO2 to this system will change the Earth dramatically is a very difficult concept to get across. And that's where I think CO2 is an issue. But calling it the ultimate commons problem, the idea there is that, yes, it is true that my activities release CO2, but the activities of every other person on the planet also release CO2. So I'm not going to change until China changes, or until... So it's very easy to put that off and say, well, I'll do something as soon as everyone else does something. That's the idea behind the commons problem. That was the difference with the CFCs. It was very easy to point to those 4 manufacturers that were producing all those CFCs and say, okay, you got to change the way you act. Now it's all of us that are reliant on energy from coal and oil and use gasoline in our cars, and it's a much more difficult problem to address. So this is just kind of finishing up that. Here's just showing the last 1,000 years of CO2 concentrations. As I mentioned, the CO2 was very constant prior to the Industrial Revolution, and now we're seeing this sharp increase from around 280 parts per million to today, we're looking at over 390 parts per million. So the third aspect that I think is a real challenge for, and actually these two, number 2 and number 3, are similar both for climate change and for ocean acidification, because they're both being driven primarily by CO2 increasing in the atmosphere. So that this commons problem is an issue for both, and as is the magnitude of the problem. And so people have seen these plots and they see this rise and you say, well, okay, CO2 is going up. Is that, you know, how important is that? So one of the things that I've tried to do in my talks is to give people a sense of just how large that number is, how much CO2 we really are emitting. So in 2010, our fossil fuel burning released about 9.1 petagrams of carbon to the atmosphere. And what I do in my talks is I ask people, so a petagram, anyone have any idea what a petagram is? So people sometimes will look at the slide and go, well, it's 10 to the 15th grams. Okay, but so what? That, I mean, it maybe sounds like a big number. Then I talk about, well, it's 1 billion metric tons. All right, well, that's starting to maybe sound like a bigger number. But what I suggest is a little thought exercise and think about how much carbon this really represents. And so I asked the question, how long do you think a coal train would have to be to hold 1 petagram of carbon? So that coal train, this picture here, a hopper car of coal, holds about 100 US tons of coal. That coal is about 80% carbon. Okay? That railroad car is about 60 feet long if you include the couplings. So the question is, how long do you think that train would be to hold 1 petagram of carbon? I won't make you guys guess. But if you go through the math, it turns out that that train would be 156,500 miles long. Put that in perspective, the circumference of the Earth at the equator is about 24,900 miles, which means that that coal train carrying 1 petagram of carbon would stretch around the Earth a little over 6 times around the equator. Now we're starting to get a sense of just how much CO2 we're releasing. And it's here where I find that people say, you know, before I didn't really think that there was any way that we could be releasing enough carbon to affect the global chemistry of the oceans. But if you think about the fact that we're producing coal that's equivalent to wrapping around the Earth, so actually if you add on to that another 0.9 petagrams of carbon, together that makes about 10 petagrams of carbon that we released to the atmosphere in 2010, and it's growing every year. That 10 petagrams of carbon means that we've stretched around the Earth 69 times. That's the equivalent, the ocean uptake of that is about 2 petagrams of carbon per year. So that means that we're dumping one of those coal trains worth of coal into the ocean every second of every day, 24/7, 7 days a week, 52 weeks a year. Another interesting issue in terms of the magnitude of the problem that's kind of unique to ocean acidification is this idea, okay, again, we just explained what's going on with the rise of atmospheric CO2, and we can show very nicely that the CO2 in the surface ocean is increasing at about the same rate as the atmosphere. But then we go on for this lovely little addition, which is to say, and that increase in CO2 is causing a drop in pH of 0.1 pH unit over the last 200 years. In fact, it's decreasing at 0.0018 pH units per year. And people look at that and they go, first of all, I don't know what pH is. And second of all, that don't sound like a big change to me. So we've also got the additional challenge for ocean acidification of explaining to people what we mean by these changes in pH. And we can say, you know, it's a log scale, it's kind of like the Richter scale, which means that a change of 1 unit is really a factor of 10 change, but I think this is another real challenge facing ocean acidification on top of the initial challenge of just understanding how much CO2 we're actually putting in the atmosphere. The fourth challenge is the complexity of the problem. Again, for climate change, we're talking about impacts that are based solely on the CO2 that remains in the atmosphere. And people will be very quick to point out that only about half of the CO2 that we're releasing stays in the atmosphere. The other half seems to be split currently between the land and the oceans, that the land and the oceans are taking up about half of that CO2. So why can't we just get the oceans and the land to take up more? And that would fix this whole problem. So that's a complicating factor for people. Then you go into looking at the impacts, the actual impacts of climate change. And you know, we have to explain that rising CO2 causes flooding and storms in some places. It causes droughts in other places. It causes wildfires in places. You've got thawing of permafrost, changes in life cycles, warmer oceans, rising sea level. All of these different things that are all coming out of this increase in CO2. And it just becomes very overwhelming and difficult to assimilate. So the complication of this whole situation is a real challenge, I think, for global warming and climate change science. It becomes even worse when we think about all of the different parties, the different stakeholders that have an interest in whether we want to consider CO2 as a dangerous gas or not. Again, think back to that CFC problem where it really all kind of ended up falling down on those 4 companies that were producing these man-made compounds. Now you've got this whole complicated array, matrix, food chain of interests in CO2 and whether we want to take action or not. And this is all a very complicating effect and paralyzing for most politicians. Even if we go down into the oceans and look at the effect of climate change on oceans, there's a whole list of impacts and feedbacks and effects that we'll see from climate change. You know, we can step through just this whole list of things that is very difficult to explain. Ocean acidification has been presented as a much more straightforward consequence of rising atmospheric CO2. It's called the other CO2 problem, or global warming's evil twin. And the idea is CO2 is increasing in the atmosphere, it moves into the ocean. CO2 is what we call an acid gas. The CO2 reacts with water molecules to form carbonic acid. Obviously, adding acid to the ocean is a bad thing. It's a pretty straightforward explanation, even if it does involve chemistry. The problem I think we really face with ocean acidification is the fact that people don't know what it is. And I thought this was a very interesting study that was done looking over a 25-day period. The number of stories in the newspaper and on the TV about the Kardashian kids was in the order of 1,000 versus ocean acidification, which was 20 times less. Where is our media really focusing its attention? On things that are likely threatening our planet? Well, I don't know, maybe they're threatening our planet too. Anyway, I think the real issue with ocean acidification is the fact that we're not getting that story out there effectively enough. We need to do a better job of doing that. Now, like I say, CO2 and ocean acidification is frequently presented as a much more straightforward consequence. And as long as we're talking about pH, that may be true. But you'll notice, this is actually from King Caldera's talk that he gave here a while back, that frequently what we do, myself included, I'm just as bad, is we talk about ocean acidification, we talk about dropping pH, and then we immediately say, and if you look at this map of aragonite saturation, you can see that this is a problem. Okay. And it is an interesting concept. So the CO2 changes how easily or difficult it is for these calcium carbonate minerals to dissolve. In particular, we think about coral reefs. So the coral reefs, all the known coral reefs in the ocean are shown with these magenta dots. And we can, using measurements and models, very accurately look at the distribution of this, this measure, this aragonite saturation horizon, or saturation state in the oceans. And we see that all of the coral reefs in the pre-industrial, when we had an atmospheric CO2 of 280 parts per million, were all found in this blue region. So where you've got saturation states that are in the 4s and 5s, the corals are very happy. They grow very well. As you move into these oranges and yellows, they're not so happy. When you get into the reds, they're basically not growing at all. They're not dead, but they're not growing at all. And then when you get below this saturation state of 1 into these very light pink and white colors, that's where you begin to actually dissolve those calcium carbonate minerals. And so we can step through, and we know this chemistry reasonably well. We can step through and say, all right, what would you have at 380 parts per million? So this is around the year 2000, around the turn of the century. You can see that we've gone from this primarily blue in the tropics and subtropics to much less blue, a lot more yellow in the subtropics. And as we move out 450, this is where we think we will be by the middle of the century, or maybe even sooner. Basically, there's almost no blue left in there. And then we start to look into where we might be by the end of this century. Some estimates go as high as 750 parts per million. And we can see that it is very obvious to anyone that's looking at this that believes what we say about Ragnar saturation, at least, that, wow, that's probably not so good for coral reefs into the future. But is it really that simple? We then go on to talk about all the different effects that we see from the biological response to ocean acidification. So where, as long as we're talking about a chemical response of ocean acidification, how is this increased CO2 affecting the chemistry of the oceans? We know that very well, and we can model that, we can measure that, we can show those changes very clearly. And it is a much more straightforward response to the rising CO2. But where it gets kind of more difficult is when we start to look at the biological response. And there we've got to start talking about, well, there'll be winners and there'll be losers to ocean acidification. And even within what we think of the losers, there are studies that give conflicting results. Or we see these complex patterns of maybe not just a linear decrease in growth rate as aragonite saturation decreases, but some of them may show something optimized to an intermediate growth rate, or maybe they even do better as CO2 goes up. So how do we explain that? This is where I think the real challenge lies for ocean acidification. And while right now there is a very strong climate change denial community that's actively working to suggest that climate change is not real, it's not happening, it's not caused by humans, we haven't really had that so much in the ocean acidification community yet. But it is coming, I guarantee it. And the people that have made those arguments so far have not really. Here's where you should stop taping this. I don't want to put this on YouTube where people can see it, but the arguments that have been made so far have been mostly geared towards the idea that, well, we're overestimating the increase in CO2 at the end of the century. And so the arguments have been that CO2 will not really be as high as we think it will be in 2100, and therefore ocean acidification will not be as much of a problem as people are claiming. What they haven't really picked up on are the complications of these biological responses. And mark my words, maybe it is good that we're documenting this. When the climate change deniers and the people that will start to fight ocean acidification start to really work on this, this is where we need to make sure that we are very clear in presenting results that are well validated and verified, because that's going to be confusing and complicating for the community to understand. So another thing that I've learned in giving my talks is, particularly when I give my ocean acidification talk, I would have people that come up to me afterwards and say, well, that was a really nice talk, but I'm so depressed now. And I feel that it's kind of hopeless. And I'm not trying to drive that hopometer down to 0. I'm not trying to say that this is a hopeless cause. I, in fact, am very optimistic about our hopes. In fact, I was raising my hand around 7. I think I was one of the first ones to raise my hand in Dr. Moore's lecture. So in an effort to try and end on a little bit of an upbeat, I think there is some hope. And I think we are starting to make a difference, particularly in the climate change. And there's been some really nice studies done recently at George Mason University in Yale. They came out with a series of reports conveniently just before the elections, but looking at the public response to climate change, even though that really wasn't much of an issue in the election, it seems. So a couple of their findings. First, they were looking at how well the message is getting through to the public. And they found that as of September 2012, 70% of the people surveyed said that global warming really was, they felt that global warming really was happening. And that's up significantly from just 2 years ago. They found that for the first time, more Americans believe that global warming was caused by humans than not. So, first time that this number's really crept above 50% in the years that they've been doing this survey. 40% felt that the world really is being harmed now from global warming. And 58% say that they are somewhat or very worried about. 44% believe, I thought this was interesting, it's still an amazingly low number that believe that most scientists agree that global warming is happening, even though the fourth assessment report said it was unequivocal. Or very likely, I guess. It was unequivocal that climate was changing, and very likely that humans are causing it. And I will just give you a bit of a preview to say the fifth assessment report will come out with an even stronger statement. So how are governments, what do people want the government to do in response to this? 88% say that the US should be reducing global warming, even if it has economic consequences. Another fascinating number. So that only 70%, I shouldn't say only, 70% of the people believe that global warming really is happening, but 88% felt that we should do something about it. I don't know who those 18% are that said, well, it's not real, but we should do something about it anyway. But kind of interesting. 73% support funding more research into renewable energies. 77% say that it should be a government priority. 92% say that the government should prioritize clean energy. It's amazing, these numbers, compared to what we're actually seeing. 25% say they always or often walk or bike to work. So people are actually starting to change their habits, hopefully. So 17% carpool. 57% say that they've changed their lights to the compact fluorescent lights, CFLs. 32% say that they have given business to a particular company because they are trying to reduce global warming. And on the opposite side of that, 24% say that they have not gone to a particular company because they are not taking steps to reduce global warming. 15% say that they've donated money or time to organizations that are trying to reduce global warming. So I found all that fairly positive. What about ocean acidification? It's not quite as rosy, I think. So they did this survey where they asked how important is it for the government to take action against reducing ocean acidification. And only 41% of the people felt that so 41% felt that the government should make this a medium or low priority. But again, I think a lot of that has to do with the fact that most people don't understand what ocean acidification is. And again, just to wrap up, I think there is hope with the new administration, or the re-elected administration. In Obama's inaugural address, he says, "We will respond to the threat of climate change, knowing that the failure to do so would betray our children and future generations." And again, following up with his State of the Union address, he says, "We can choose to believe that Superstorm Sandy and the most severe drought in decades, and the worst wildfires some states have ever seen, were all just a freak coincidence. Or we can choose to believe in the overwhelming judgment of science and act before it's too late." Pretty strong words coming from a president. And then he followed it up by saying that if Congress isn't going to act, he is. So just to conclude, number one, I think it's getting harder and harder to deny that humans are having a profound impact on the Earth. And the evidence is just going to continue to accumulate, and it should become easier to get that message out that climate change and ocean acidification really are happening. As Dr. Moore said, we have a moral imperative to make a difference, but we need to recognize and address the barriers of people's beliefs in climate change and ocean acidification, and address those as we're making our research and our new findings available to the public and the policymakers. It's not enough just to keep saying the same thing over and over again. We need to understand why is it that what I'm saying is not having an impact, or what are the things that I should be focusing on that might convince them to do something. And finally, I'll just state that now is the time to take a more proactive role in engaging and educating the general public, particularly with ocean acidification, but also with climate change. Thank you. Thoughts, comments? People want to rip me apart? Am I totally off base? Yes.
So the two things that really struck me were the political differences between Republicans and Democrats occurring basically, well, I mean, I'm interpreting it as right after Inconvenient Truth, and that basically politicized the issue for people, and it made, Democrats say, "Oh yeah," and it made Republicans say, "No way." And so that I think is a really telling. I mean, if that's my interpretation, I wanted to see what you thought about that. Yeah. And the second figure that you gave that really was shocking to me was this idea that far more people believe global warming is a serious issue than believe that scientists agree on that point. And that's crazy to me that that's the case. And that may be the most shocking thing that you said, I thought. So I was just wondering if you could comment more on those two things.
Sure. So on the first point, so some are arguing that it was Kyoto where the difference really started. But as I mentioned, around 2007 is when they really ramped up. So that's when spending on the climate change denial propaganda, if you will, really tripled from previous efforts. Now, whether it was the movie or the Nobel Prize, it's hard to say what any of that was. I think part of it too, I think there is some validity to the fact that as we moved into the recession, that people were less inclined to believe something that would not only make the recession worse if they were to believe it. It's just as easier to say, you know what, I don't believe that, I'm not even going to face that because I have bigger issues to deal with. So there are all these things that kind of happened all at once that I think led to that. The second point about more people believing global warming is occurring than believe scientists agree, actually speaks to another issue that is a complication with climate change. Is most people have no idea what climate is. They equate climate to weather. And what we find is that, or what social scientists find, is that when you've got a very hot summer, people tend to believe that global warming is real, more so than when you have a really cold winter with big snowstorms. And the fact that this survey was done in September, right after the summer, may affect that. So what the people are doing is they're not relying on the scientific, say, well, the scientists are still arguing, but man, it was hot this summer, so yeah, I think it's real.
You talk about, obviously, just the United States, but if we're the only non-ratification country for the Kyoto Accords, does the rest of the world get this? And if it does, then what are they doing if part of the problem is the terminology you're using?
Very good question. I think in general, most of the rest of the world does get it. And the real difference is that, particularly in Europe, the Europeans have really embraced the idea of climate change. And they are trying to take steps to resolve it. Now the problem is, even if you accept that climate change is real, how do you actually implement change? I mean, it's not easy. Like I say, carbon is everywhere, fossil fuels are everywhere. And it is a real challenge to address it. So while I think, at least again, my observations of public opinion and policymakers in other nations are trying to address this, they're having difficulty figuring out exactly how to fix the problem.
But that's not the perception problem, and you're talking about perception.
Right. But in the US, we have to fix the perception problem before we can even get to that next problem of how do we actually really address it. Yes?
I really enjoyed your talk. One thought I have about the difference between CFCs and fossil fuels is that in the case of CFCs, there were some ready alternatives to the CFCs. And the same industry that created those CFCs created the replacements in fairly short order. Whereas with fossil fuels, the very existence of a major industry is threatened by saying that climate change and ocean acidification are real. So that's just that fuels the misinformation campaign in my view, and that's just a really big challenge to overcome. So I really enjoyed your treatment of it. It's just one.
No, it's a very good point.
All right, let's do one more, and then we'll have time at the reception for other questions.
I just wanted to point out that the perception, if we get the perception in line, Germany is a real poster child of how action can be a solution in the right direction, because currently they're raising by 25% of their electricity from renewable energy sources. It's divided between wind and solar and water power and some others, biofuels. But 25% is a significant amount. That doesn't really solve the transportation problem, which is 80 to 95% by fossil fuels, by oil. But for electricity is a good step in the right direction, and they've done it. They're doing it.
I wonder whether I could take the floor with my accented English. There is a difference, or in this country, in our country here, it is difficult to, or more difficult than in other countries, to convey the scientific view because of the rule that the media has to always also send the opposite without giving the percentage. 98% of the scientists believe in warming. That is not so in other countries. So the majority of the scientists have a much easier time to convey their view in an accepted manner.
It's a great point.
Yes.